Today we're going to quickly review 5.1 and 5.2. 5.1 is rational exponents. A rational exponent is an exponent that is a fraction. So we have something like a to the m over n. The number on the top is the power. The number on the bottom is the root. So when we have a to the m over n, we could take the nth root of a and then take that to the m power. We could also take a to the m power first and then take the nth root of that. Generally, it's it's easier to take the root first because you're dealing with smaller numbers. So if I have a to the 2/3 power, if I take the root first, I'm going to take the cube root of 8 and then square it. The cube root of 8 is 2, so that's 2 squared, which is 4. Now I could have taken the power first. I could have taken the cube root of 8 squared. 8 squared is 64, and the cube root of 64 is still 4. Now this reminds me that I was going to tell a math joke, but I was just too squared to tell one. Now, remember the principle of multiplying numbers with the same base. When we multiply numbers with the same base, we add the exponents. So x to the 3rd times x squared, 3 plus 2 is 5, that equals x to the 5th. We're going to use that to solve equations with rational exponents. So what is the solution of 3 to the x over 2 times 3 to the x over 3 equals 3 to the 9th? Since the numbers have the same base, 3, when we multiply, we're going to add the exponents. So we're adding x over 2 plus x over 3. Now, those don't have a common denominator, so we need to find a common denominator first, which would be 6. So we'll multiply the top and the bottom of the first fraction by 3, and multiply the top and the bottom of the second fraction by 2. So we get 3 to the 3x over 6 plus 2x over 6 equals 3 to the 9th. Now we have the same denominator, so we can add the two fractions. So 3x plus 2x is 5x. And now we have a single term on each side of the equal sign. Since the bases are the same, they're both 3 and they're equal, then the exponents have to be equal. So we just set the exponents equal to each other. 5x over 6 equals 9. And now to solve for x, we'll multiply by the reciprocal, which is 6 over 5. And so we get x equals 54 over 5. Now, what if the equation has numbers that don't have to have the same base? Well, then we want to write them with the same base. 27 is 3 to the 3rd power. And over on the right side of the equal sign, we have a 3. So the same base for each would be 3. So 27 is 3 to the 3rd. And then to the x minus 4 equals 3 to the 2x minus 6. And now when we take a power to a power, we multiply the exponents. So we're going to multiply 3 times x minus 4. So we get 3 to the 3x minus 12 equals 3 to the 2x minus 6. Now again, we have a single term on each side of the equal sign, and it has the same base. The exponents have to be equal then. So 3x minus 12 has to equal 2x minus 6. So now we'll subtract 2x from both sides. We get x minus 12 equals negative 6. And then we'll add 12 to both sides, and we get x equals 6, and that's our solution. And that's 5.1. Now, 5.2 is exponential functions. Exponential functions are in the form f of x equals a times b to the x power. A is the initial amount that we start with when x is 0. B is our growth or decay factor, what we're multiplying by each time. And remember, an exponential function graphs to a curve, and then it has an asymptote, a line that it approaches but never touches. So now we want to write a function represented by the data in the table. Well, when we look for the y values, the column with f of x, 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. And 108 times 3 is 324. We're multiplying by 3 every time. So that's our growth factor. And our initial amount when x is 0 is 4. So that's our a value. So our equation is f of x equals 4 times 3 to the x power. Now, when we look at the graph, we want to write a function. Well, we can see this function is decreasing. It's getting smaller as we go from left to right. How do we get from 128 to 64? Well, we divide by 2. But in our function, we want to know what we multiply by. So dividing by 2 is the same as saying times 1/2. And 64 divided by 2, or 64 times 1/2, is 32, and so forth. Half of 32 is 16, which we see over in the left over here, and then half of 16 is 8, half of 8 is 4. So we're multiplying by half every time, so that's our decay factor. And then our initial value when x is 0 is 128. So our function is f of x equals 128 times 1/2 to the x power. And that's our review of 5.1 and 5.2.